A particle moves in a circle of radius 5 centimeter with constant speed and time period 0.2, it's 0.2 pi seconds. The acceleration of the particle is, so very simple question. So we know that a net is equal to root of AC square plus AT square. What is AC? AC is centripetal acceleration, and what is AT? Is tangential acceleration. Now here a net would be equal to root of AC square plus, see, since it is given that the object is moving with constant speed, right, the constant speed which is v is equal to k, implies the tangential acceleration will be equal to 0. So what we get is a net is equal to AC square, sorry, root of AC square, which is AC. And what is AC? AC is omega square into r. What is omega? Omega is 2 pi by t. So this becomes 2 pi by t the whole square into r. So this is 4 pi square by t square into r. So we can write this as 4 pi square. How much is t? T is given to us as 0.2. This becomes 0.2 square into pi square into r is 5 centimeter. So that is 5 10 to the power minus 2. So what do you get by solving this? This is equal to pi square by pi square is 1. So what we get is 4 into 5 into 10 to the power minus 2 the whole upon 0.2 square can be written as 4 into 10 to the power minus 2, right? So now 10 to the power minus 2 by is 1, 4 by 4 is 1, so what you get is 5, which makes the correct option as option D, 5 meter per second square. So now you may think, why did I convert 5 into 10 to the power minus 2? Because the option says only meter per second square, whereas what's given to us is 5 centimeter. Okay. See, I would actually suggest that while try solving this question, you should learn a couple of things in addition to this, which will help you in improvising your concepts. We'll discuss that as 3 cases. So, circular motion can primarily be divided into 2 types. One is uniform circular motion and the other is non-uniform circular motion. Now non-uniform circular motion would be again of 2 types: accelerated circular motion and retarded circular motion. You may be thinking, why am I telling you this here? Because many questions have been asked in the previous year, say for JEE exam, for the NEET exam, for the IIT Advanced. They rely upon some basic concepts. So this question, thus, since it covers A net, AC and AT, I thought of including the concept explanation also. That's it. So that's the purpose behind this. So let us now discuss these 3: uniform circular motion, accelerated circular motion and retarded circular motion. And what in that we'll be discussing about A net, AC and AT. How do we do that? We make use of a figure to understand the concept here. So we'll be discussing, let us contrast accelerated circular motion and retarded circular motion. So okay, let us also see what is uniform circular motion. See, when we have uniform circular motion, say this is the center of the circle. So this represents the direction of centripetal acceleration, and velocity is always tangential. So what I assume is the object is rotated in this direction, right, in the clockwise direction. So the velocity is like this, and the angle between centripetal acceleration and velocity is 90 degree. Now let us see what happens in the case of accelerated circular motion. So when we have accelerated circular motion, what happens is velocity increases. So say if this is the center and we are considering this point here, so this will represent the direction of centripetal acceleration, and this here will represent the direction of velocity. And what we need to understand here is that this also will represent the direction of tangential acceleration, which means we have AC, we got AT, and therefore this will represent a net, and a net will make an angle theta with the velocity vector. And what is the speciality of this theta? This theta algebraically is acute in nature, right? Something which we will use again and again while solving problems, especially at the JEE mains level. Now let us see what happens in retarded motion. So when it comes to retarded circular motion, see, we got an object here executing circular motion in this direction. Okay, so let this be the center of the circle, and this is the point we are trying to consider here. So this represents the velocity vector, and velocity here is decreasing. This would represent the centripetal acceleration, and since the motion is retarded, so this what we have is retarded circular motion. Since the motion is retarded, what we can say is this will be the direction of tangential acceleration, right? And therefore the resultant acceleration or the net acceleration would be a net. Well, of course, to make such a line, a longer line will mean the magnitude of resultant is more. Let us not keep that. Okay, so this is the a net, and look at the angle made between theta. Look at the angle theta made between a net and velocity. That angle theta here is obtuse in nature. Okay, so uniform circular motion, no tangential velocity, only centripetal acceleration. Non-uniform circular motion, accelerated in nature, velocity and tangential acceleration are in the same direction. Angle made between the net acceleration and the velocity vector is acute. Circular motion, non-uniform circular motion, retarded circular motion, tangential acceleration is opposite to the velocity vector. Tangential acceleration, centripetal acceleration, the resultant is a net, which makes an angle theta with the velocity vector v, which is obtuse in nature. So that's the concept that we need to study with respect to this problem. Having said so, let's move on to the next question.